we're going to be looking at the website known as Quora today. If you don't know about it, it's just a website, a place people can ask questions, and anybody can answer. So, if you happen to be an expert in dust motes, someone's probably got a question for you to answer. But today or this evening, we're going to be looking at lesser known scientific facts. There's a lot of information out there, and hopefully my channel is, I think to the extent I'm going to have success with this channel, it's going to be due to at least partially my ability to filter information for you guys. That's what makes content valuable. Filtering out from the noise some sort of patterns that are ideally useful for your life, and if not immediately useful, a interesting piece of the puzzle that you'll eventually put together to make sense of the world. And that's really my whole agenda on this channel. Let's Find Out means, for me, there's a lot out there, and only some of that is worth finding out about. And I'd like to find out the most interesting, useful, compelling facts that keep us in awe and amazement of the situation we're all in, the world, thrown into the world, as it were. Let's get started. Water can boil and freeze at the same time. You might not have realized this. So it's called the triple point, and it occurs when the temperature and pressure is just right for not 2 but 3 phases, gas, liquid, and solid, of a substance to coexist in thermodynamic equilibrium. And what that means is, let's see, pressure and boiling point. A liquid at high pressure has a higher boiling point than when a liquid is at regular atmospheric pressure. So as you go up and the air thins on the opposite end of that spectrum, as the pressure decreases in the atmosphere, then the boiling point lowers as well. So it doesn't take 212 degrees Fahrenheit to boil water, but actually 200 degrees. So if you get that just right, then I suppose triple point is, so at 32.018 degrees Fahrenheit and the pressure of 611.657 pascals, or 0.006, 03659 atmospheres. At that perfectly balanced combination with only minuscule adjustments to either of those variables, an individual would be able to, it's possible to change all of the substance from ice to water to gas very rapidly within small amounts of time. So I guess the practical aspect of that would be for some sort of technology that would benefit and would become extremely useful if we were to rapidly change the water inside it from water to ice to gas. Maybe in space that would be useful somehow to, if you have to rapidly change the volume of something, maybe, because ice expands. When water turns to ice, its volume actually increases So it's pretty interesting. Now, a single solar flare can release an equivalent energy of millions of 100 megaton atomic bombs. A single solar flare. And you look at those sometimes, they're pretty much the size of entire planets. Size of the Earth. And you can imagine that, you know, even though they're 90 million miles away, it's an incredible amount of energy. It's the Death Star, really, I guess. That's amazing. 100 million, millions of 100 megaton atomic bombs. And then it gets, sometimes, coronal mass ejections. CMEs get burst right out into the solar system. And, of course, we're so small with respect to the volume of the solar system. So it's certainly pretty rare for the coronal mass ejection to be exactly on the trajectory towards Earth. But no doubt it would wipe out the entire planet if it ever did hit the Earth, even including our, considering that we have a pretty significant magnetic field blanket wrapped around our planet. It's still a huge potential threat to all the life on our planet. So number 3, cats always land on their feet, to go to something a little more trivial. But still interesting because it took physics for us to really figure that out. It's the fact that cats can twist their bodies in 2 separate motions at once. The front half and the back half twist to create a kind of gyroscopic effect. And this ensures a rapid rotation. So it's kind of like when you, well, it's the same principle, roughly, I would say, as being able to tuck your arms in when you're spinning in a chair, or at a higher level of human ability when an athlete is able to do a triple axel on the ice rink. And they tuck their arms in to get a really, really tight, faster spin. And that's what cats are able to do, apparently. So, it's pretty interesting. Speaking of spinning, we've all seen the YouTube channel do that, but it's kind of hard to picture. This spinning basketball, I think the one I saw was a spinning basketball thrown from a dam in what's called the Magnus effect. And it's the same thing that allows a baseball pitcher to curve the ball when they're throwing a curveball. They put a spin on it that interacts with the air and creates a drag more so on one side, and therefore creates like a force that makes the ball move. So the Magnus effect, it's like an unbalanced force that makes the ball kind of drop or move forward or whatever it might be relative to the direction that you put the spin on the ball. When the air on the front side of a spinning object is going in the same direction as its spin, which means that it's getting dragged along with the object and deflected back. Meanwhile, the air on the other side of the ball is moving in the opposite direction, so the airflow separates. So maybe that looks like, I'm just doodling earlier. I forgot to incorporate the doodle because I love pen sounds. But let's see if so the balls going in that direction. In the airflow, and now if it's spinning in this direction, so you see the airflow here. So if we put a spin on the ball like that, and the ball's generally moving in this direction right here, then what happens is the airflow compounds. It creates a superposition of like forces. What's it called when two waves supplement each other? They either cancel or they compound. It's like an amplitude effect. I was looking for destructive and constructive interference patterns, but I don't even think that's really applicable here. It's more about how, you know, if you put a car on a treadmill and you made the treadmill go fast, the car wouldn't have as much traction as if the treadmill was really going the opposite direction as its rotation, the rotation of its tires. Whereas this, easiest way to visualize the overall effect of what's happening here, the effect of the spin reacting against the air. If the air is flowing this direction, and the ball is spinning that direction, so the top is going to be resisting the airflow, if you can see, and the bottom is actually going to be going with the airflow. So the bottom isn't putting up any resistance, so there's much less drag, much less friction in that direction. Whereas the top here, because it's directly opposing the spin of the ball, is directly opposing the direction of the airflow, there's resistance. It's like when you push on a table. If you push on something that's already going down, you don't really feel much of a resistance. If you push on a table, something solid, the resistance that the firm, rigid object you're pushing on gives you is going to create, it's going to make you, give you an opposite counteracting force, what's called a normal force in physics. And that's going to push you away from the exactly the opposite direction from the direction you're pushing. And so what that means is that the ball is going to be, based on that, we can tell that the ball is going to be pushed in the downward direction for our little diagram here. So anyways, that's there's a whole area of engineering called aerodynamics. No, it's not. It's aerospace engineering, I guess. I definitely wouldn't get hired at SpaceX, but it's fascinating that, you know, let alone airplanes and jets, let alone rocket ships that go orders of magnitude faster than jets. At least once they're out of the thickest parts of the atmosphere. It's like when you're diving in a pool, the water seems pretty malleable, pretty flexible, pretty fluid, versus jumping off a bridge. If you guys have ever done that or gotten close to it, if you get up more than about 20 feet, the water pretty rapidly starts feeling more and more solid rather than fluid. And it's an interesting change of dynamic when objects start to have a greater velocity than the drag and the friction forces of something as innocuous as the atmosphere, the air that we breathe. I can move my hand pretty quick, but if I'm going out the window, if I stick it out the window of a car driving 100 miles an hour, I'm not going to be able to move my hand so freely, especially if it's like this, capturing air. So that fascinates me that, we've, as a species, have done enough work to be able to put scientific equations and general understanding of the way atoms interact with particles, with other atoms at greater and greater speeds. Ultimately, that's where relativity kicks in if you take that thought experiment, I guess, train of thought to its ultimate conclusion, being what happens with particles when they interact at the speed of light, not just 1,000 miles an hour or 17,000 miles an hour like the space station travels, something like that. So that's, again, putting pieces of the universe together to pieces of seemingly microscopic perspectives of the universe together to ultimately, hopefully, ideally, make a comprehensive, somewhat comprehensive at least, understanding of the universe. Here's a completely useless fact, other than maybe it tells us something about humanity in our aversion to a particular letter of the alphabet, because only one does not appear in the periodic table. I'll give you guys 5 seconds to try to come up with an answer. Put that in the comments below if you're still awake, or if you're paying attention, you care. Speaking of the letter, it's the first letter of the most recent Jeopardy phenomena, and that would be James. So it's the letter J. What is J? Does not appear on the periodic table. Yeah, pretty useless. But speaking of the periodic table, did you know that, you probably did know that bananas contain potassium, but what you might not have known is that potassium is a relatively unstable element, and so therefore it decays more than most elements, making it slightly radioactive. You might not have realized that, but it's nothing you need to worry about, since you gotta eat about 10 million bananas at once to die of radiation poisoning. So, I think we're all, as much as I like smoothies, I guess I'm pretty safe. Now, here's a counterintuitive fact. Some of the best kinds of facts are counterintuitive. Hot water freezes faster than cold water. I wouldn't have thought that. This fact seems counterintuitive, but it's called the Mpemba effect. Mpemba effect. There's an M before the P, that's hard to pronounce. Mpemba effect. After a Tanzanian student named Erasto Mpemba, who told his teacher that a hot mixture of ice cream froze faster than a cold mixture. This is because the velocities of water particles have a specific disposition while they're hot that allows them to freeze more readily. If proven correct, the finding could also have implications in daily life, like cooling electronic devices, which is a huge barrier to technological advancement right now, as we're just trying to figure out, we could make faster and faster and smaller devices, Although we are kind of hitting the atomic limit with that too. But nonetheless, anybody who's a gamer knows very well the pitfalls of modern technology and just how quickly especially our fastest, most powerful microchips tend to heat up. And as an inverse, I guess, effect of the one we just described, cold water actually heats up faster than hot water, I guess. It's called the inverse Mpemba effect as of now. So here's one. Everybody knows we got DNA. That's pretty much, it's 4 separate compounds set in billions and billions of different combinations that essentially dictate and inform all the rest of the cells as we're growing and consuming nutrients that help us grow and help our bodies. It's another synonym for grow. Evolve into our final form. But did you realize just how much DNA we have? There's over 3 billion base pairs of DNA in human genes and over 25,000 genes in the human genome. So, the 3 billion base pairs are segregated into 25,000 segments that all each have specific, I guess, patterns that are communicated to the rest of our body to represent and ultimately manifest traits like, hair color and skin color and anything from height to chemical oddities that might be predispositions for excessive wellness or excessive disease, I guess. An entire copy of that genome exists in each of the 10 trillion cells in our bodies. If all that DNA were lined up, it would cover the distance between the Earth and the Sun 100 times. So that's 900. It's pretty much 1 billion miles worth of DNA. That's insane. That's bewildering. And thanks to, imaginative minds that are creating incredible scientific breakthroughs, and then also fiction authors that are keeping our imaginations and optimism stimulated, it really just helps stay in amazement of the world. It's fascinating, I think, that we have no idea how DNA came to evolve, It's so elegant, so simple, yet it's like binary logic. It creates the entire network of technology that we use, from the light to the microphone to my cell phone recording me right now. The image that you're seeing of my face is captured and reproduced on your screen as just a series of millions, maybe billions, of ones and zeros. That's it. And the ones and zeros are put in increasingly longer segments or patterns to represent larger values. Other than just 1 and 0, it's multiples of 2. So it's 2 and 4 and 8, 16. And using just 2 simple units, in DNA's, in our case it's 4 units, we can we create the body and we create technology. It's just, I don't know, it's cool. It's for anyone to think that life is meaningless. It's like, just go out and read a book about what we know about history and science and even philosophy. And man, if you think we're at the end of the road of not just scientific but just human discovery and human exploration and venturing into physical space, you know, and in the sense of going out and exploring the solar system and the stars, like the Voyager spacecraft, and the bottom, the depths of the 7 miles down in the Marianas Trench, but also the intellectual space, the emotional space, the spiritual, numinous space of our brains. We haven't even begun to understand ourselves, you know, what makes us tick, who's actually in control. When you want to lose weight and you're like, consciously, I'm gonna lose weight, but then you cheat and you eat a cupcake or whatever. Who is that making those contradictory decisions? I don't know. So much more to explore. So number 10. Many of you know what a superfluid is, but it bears repeating nonetheless. It's a phase of helium. So water is hydrogen, 2 hydrogen atoms, 1 oxygen atom, H2O. But if we took pure helium, which is normally in a gas used to inflate balloons, helium can work against gravity if the temperature of it is set low enough. So as temperatures generally decrease, every element, every molecular configuration all have their own boiling and melting points. But generally, gases condense into water, and as the temperature lowers, it goes from gas to water, and water to a solid. Now, if we take this pure helium and you lower the temperature enough, I guess maybe helium never reaches a solid, but it goes from gas to a liquid, and when it's cooled down to just a few degrees from absolute zero, 460 below zero Fahrenheit, or negative 273 Celsius, it turns into a superfluid. There you are. Meaning it can flow without friction. And remember, like we were talking about fast-moving objects through the atmosphere, through air, that resistance you feel is a form of friction. In the air it's called drag. Or maybe in the water, maybe in fluid too, it's called drag. But nonetheless, there's no friction. That means there's zero resistance against surfaces. So if you start a movement of this superfluid, even if it's sitting in a basin, in a jar, like so, even if it's sitting in a jar like this, a glass container maybe, mind you, it's negative 460 degrees below Fahrenheit. If you somehow start it molecule thin cracks. Yeah, you might not even have to start it, but it's somehow, just because of the weird counterintuitive phenomena of not having friction, we're just not used to that in everyday life. Your butt in the seat, the tires on the road, I mean, anything, anytime you feel anything, friction is what's keeping this pen from sliding out of my fingers right now. This stuff is so interesting, it just flies. It goes against gravity and just leaves. I guess it wants to, it's so fluid. It's like, I was about to arrive at the word superfluid without thinking. It is beyond a fluid, like Superman is beyond man. It's super fluid. It's so fluid that the general properties of a fluid, which are, if you pour a fluid out, it wants to submit to gravity as finally as it's able to. And this thing is so super fluid that, I guess, instead of defying gravity, I think it's actually obeying gravity to such an extent that we're not familiar with anything with those properties. It's so in obedience to gravity that this cup wouldn't be enough to contain it. It would want to be completely flat and evenly distributed under the force of gravity, I believe, is what that's how I interpret it, at least. So it would want to climb over the walls of this cup and find its way onto a completely flat surface so that there's no more uneven distribution under the weight of gravity, or the force of gravity. Even if you have a molecule thin crack, again, because no friction, it just leaks right through that. And once it starts flowing, it never stops, like a fountain. But you might ask, well, if it's like a perpetual machine, why don't we just use that to power things? It's because it takes a ton of energy to cool anything down, even in space, that cool. So the energy it takes to create those conditions, create a superfluid, doesn't balance out. Let's see, where are we here? Alright, let's do a couple more. So the average human body carries 10 times more bacteria cells than human cells. So, I don't know if by weight, I think it's something like, hold on, I gotta look that up. It's some ridiculous number by weight is bacteria cells. Let's see, bacteria by mass in human body. The human body contains trillions of microorganisms, outnumbering human cells 10 to 1. Because of their small size, however, microorganisms make up only 1 to 3% of the body's mass. So in a 200-pound adult, which unfortunately is exactly me, 6 pounds, 2 to 6 pounds of me is bacteria. But they play a vital role in human health, so I don't have to jump in the shower just yet. That's funny. Yeah, in fact, we couldn't survive without them. And to help you understand that, just think about what it takes to digest food. It's actually something I recently learned, actually, is that to digest food, we actually rely heavily on gut bacteria. So the bacteria in your gut actually, I don't know if this is irrefutable yet, or if this is still just a hypothesis, but the bacteria in our gut apparently inform our urges, our cravings. Sorry, that was on the tip of my tongue. Our cravings. So partially, our bacteria in the gut, I think our body is, in a way, they help break down. So you want to have, that's why you have antibiotics or probiotics, which means good bacteria or good living organisms in your body. That can be very beneficial. So yeah, I think it's kind of weird to think that there's creatures that don't have human DNA just surrounding the walls, the lining of our guts. Yeah, this is interesting because, speaking of gravity a lot, we're actually taller in the morning after we've been stretched out, laying on our backs or our sides all night. And when we're walking around all day vertically, gravity compresses the discs and the fluids in our bodies to make us about, on average, half an inch smaller at the end of the day. So always measure yourself in the morning, guys. Let's see if... Alright, this is another really awesome phenomenon, maybe a little more interesting for the engineering-oriented mind, but if two pieces of metal touch in space, mind you, space is so cold, we would instantly pretty much freeze. I don't think it's near zero, but it's close to being near absolute zero, which is like negative 400 something degrees Fahrenheit. This phenomena is called cold welding. It's where two metals touch in a low enough temperature, they will bond and be permanently stuck together. And as you can imagine, that's certainly a video I believe we can find on YouTube. But, let's see. Cold welding in a vacuum. Yeah, of course, Veritasium has a video on that. Hey, how about this? Talking about being inspired by the plethora of the world, the universe left to explore. We're nowhere near knowing what, the ultimate nature of the universe. There's so much left to know. As far as we know right now, it could always change, of course. That's the beauty of those that actually practice science and not dogmatic science, where they just believe everything they're told, or they're too rigid to change their theories because at least too rigid to change their theories in the face of facts because they too closely identify with their life's work. So that's always something to watch out for. Egos get in the way of truth. But the universe is made up of 50, not million, but billion galaxies. 50 billion galaxies. In the Milky Way alone, there might be as many as 100 billion Earth-like planets. So, you still think we're alone? Who knows? I'd like to do a video on the Drake equation sometime soon. There's a good chance that there might be many planets out there that have a lot of life, but not necessarily evolved to the complexity and intelligence, relative intelligence that we have right now. Here's an interesting little tidbit. It's that an individual blood cell takes about 60 seconds to make a complete circuit around the human body. Now, is that a coincidence that we broke the day up into 60-second? That's 24 times 60. Like 1,400 something intervals. 24 times 60, what is that? Maybe 4 times 60 is 240 plus 1,200, so 1,440. 1,440 minutes a day. Is there a reason? Is that maybe... Is there some sort of correlation between our arrival at breaking the day up into 60 units of 60? I don't know. Maybe. The human brain makes up only about 2% of a person's body weight, but needs 20% of the oxygen and 15% of the energy used up by the heart is attributed to the brain. That's, the brain isn't the only thing that helps us, think and feel, but it certainly is the capstone, of our being. So, yeah, the brain is such a sphinx that we have yet to crack. I think it's beautiful. It's a beautiful thing. So much left to explore about it. And on that note of relative optimism, I guess, I'm going to leave you guys. Hopefully you learned some interesting things and you can enjoy this enough to zone out, sleep, or just focus, procrastinate. Either way, whatever you used me for, thank you for using me, guys. Thanks for tuning in and watching. As always, I greatly appreciate your viewership and your subscriptions and comments. I think I really enjoy the comments more than anything, so let me know what you thought. And sincerely, I really enjoy your feedback. It really helps me know what to do or what not to do. And it's just fun to engage with all of you. So, hope you guys enjoy it. But if not, let me know. Let me know what you didn't like about it. And with any luck, we learned a little bit more about the world than when you hit play to begin with. So, get some sleep, and we'll see you guys next time. Bye.